Hello students, in today's class we'll see Z transforms of standard results, that is nothing but standard Z transforms. Here we are going to use the Z transforms function and get the important results to simplify the problems based on Z transform. Z transform of some standard functions. So we'll see what is that Z transform of standard function. So the first one we'll see as Z transform of k raised to n. So we'll see what is Z transform of k raised to n. So here how to solve we'll see. So by definition we know that Z transform of un is nothing but summation n from 0 to infinity, okay, un into z raised to minus n. This is our definition of Z transform. So here in place of un what we have k raised to n, we will replace it here. So therefore Z transform of k raised to n is equal to summation n from 0 to infinity. In place of un we are replacing kn, so it will be k raised to n into z raised to minus n, so which can be written as n summation of n from 0 to infinity k raised to n. This z raised to minus n can be written as what here, 1 upon z raised to n, so which can also be written as n from 0 to infinity k upon z whole raised to n. So this we can expand it as what here, Z transform of k raised to n is equal to, so this we can write it as what here, if means expansion of this 1 plus k upon z plus k upon z whole square plus k upon z whole cube plus so on. So the right hand side, that is the series on the RHS is a geometry. You can see that it is a geometric series, is a geometric series of the form what here, 1 plus r square plus so on, whose sum what here, sum to infinity is what here, 1 upon 1 minus r, where this r is nothing but what here, k upon z. So using this concept of geometric series, so we can conclude our Z transform of k raised to n is equal to what here, 1 upon 1, we are using nth form. So nth form of this series is nothing, so it means nth form of 1 plus r square plus so on is nothing but what here, 1 upon 1 minus r. Okay, so here we'll use r is equal to k upon z in this nth form, means it is also same. So it is nothing but 1 minus k upon z, or on taking LCM we'll get z of k raised to n is equal to 1, means I'll write here only. So 1 divided by, if you take LCM, it will be z minus k divided by z. This z will go up, so we'll get z divided by z minus k. So remember, this is one of the very important and standard result of Z transform. So Z transform of k raised to n is equal to z upon z minus k, or I can say that similarly Z transform of, if they ask a raised to n, we can write what here, z divided by z minus k. So this is first standard what here function of our Z transform. In using this only, we'll use many of the standard result here. So we'll see that what is that some of the standard results. Second one we'll see. So Z transform of 1. So we know that Z transform of k raised to n is nothing but z divided by z minus k. So here putting k is equal to 1, if you apply k is equal to 1, and the result k 1 raised to n is nothing but always what here, 1 only. So therefore the above situation, that is Z transform of, replace k is equal to 1, so it is 1 raised to n divided by z divided by z minus 1, that is nothing but 1 raised to n is nothing but 1 only. So Z transform of 1 is equal to z divided by z minus 1. This result you need to remember. So Z transform of 1 is nothing but what here, z divided by z minus 1. Next few more results we'll see. So to find the few more results we need to remember here. So what is that, we'll see first here. So few more results by using the one of the property. So we'll see what is the property first. So property is Z transform of n raised to k is equal to minus z into d by dz of Z transform of n raised to k minus 1. So this property you need to remember for few more standard results. That is Z transform of n raised to k is nothing but minus z into d by dz of z of n raised to k minus 1. Okay, so using this property we may go forward here a few more standard results, but while finding the few more standard results of this Z transform, we need to remember what is Z transform of 1, what is Z transform of k raised to n. So keeping those kind in mind, we'll go for the next result. So result number 3 we'll see here. So result number 3. So I will use the condition when k is equal to 1, will apply here in this above situation. That is, I will give as property as 1. So when k is equal to 1, so 1 becomes, that is z of n is equal to, because k is 1 means n raised to 1 is k is 1 means n raised to 1, n raised to 1 is n only, is equal to n means z of n is equal to minus z d by dz of z of n raised to k is 1 means 1 minus 1 is n raised to 0, which is nothing but minus z d by dz of z transform of n raised to 0 always is what here 1 means any value raised to 0 is always 1 here. So which is nothing but minus z d by dz of, we know z transform of 1 result just now we have done. So z transform of 1 is what here, z transform 1 is z divided by z minus 1, we'll use it here. So z transform of 1 is nothing but we'll apply z transform of 1 is what here, z divided by z minus 1. Now we'll simplify this. So minus z as it is, we need to apply differentiation of z upon z minus 1 with respect to z, means we need to apply u upon v rule, that is quotient rule, denominator square z minus 1 square, keep z minus 1 as it is, differentiation of z with respect to z is what here 1 minus keep z as it is, then differentiation of z minus 1 with respect to z is what here 1 minus 0. So on simplification we'll get, that is minus z of z minus 1 whole square. So open the bracket, z minus 1 open the bracket minus z. So plus z minus z cancels, what we'll get here, which is nothing but minus z into minus 1 divided by z minus 1 whole square, multiply this minus z inside, we'll get, that is we are finding z of n, that is nothing but if you multiply we'll get minus minus plus, so z divided by z minus 1 whole square. So this is one of the standard result. If z transform of n you find, so the resultant is what here, z divided by z minus 1 whole square. So this is one of the standard function of our z transform. Then fourth result we'll see, when k is equal to 2 in 1 if you apply, that is what is 1, 1 is what here, z of n raised to k is equal to minus z d by dz of z transform of n raised to k minus 1. This is our result number 1. If you apply k is equal to 2 this entire situation, we'll see what here, that is z transform of n, k is 2 means n square is equal to minus z d by dz of z transform of n raised to, k is 2, 2 minus 1 is 1, so n raised to 1 is n itself. So which is nothing but minus z d by dz of, just now we came to know that z transform of n is what here, z divided by z minus 1 whole square. So the same situation, z transform of n is nothing but what here, we'll apply z transform of n, the direct result is nothing but it is z divided by z minus 1 whole square. Now again we'll simplify, so we'll differentiate z upon z minus 1 whole square with respect to z, so which is nothing but that is z transform of n square is equal to minus z minus 1 square, already square is there, again square it, it will become what here, I'll write like that. So z minus 1 whole square of whole square, then z minus 1 whole square will keep as it is, differentiation of z with respect to z is 1, minus, keep z as it is, differentiation of z minus 1 whole square is 2 times z minus 1 into differentiation of z minus 1 is what here? 1 minus 0. So therefore, on simplification of this above situation, that is z of n square is equal to minus z. So I will keep the brackets as it is. So z minus 1. So among the above we have two terms. This is completely one term and this is another term. So among this I will take z minus 1 common. So what left here? So z minus 1 whole square into 1 is what here? Z minus 1 whole square. 1 I had taken outside, that is z minus 1. One time I had taken outside. One time is left here, that is z minus 1 is left inside, minus this z minus 1 is out. So what left only here? Z into 2 into 1 is what here? 2z. So whole divided by, so z minus 1 square into square, it becomes z raised to 4. So this z minus 1 one time, and among this 1 get cancelled. So therefore what will get? Z of n square is equal to minus z. So if you open the bracket, z minus 1 minus 2z divided by z minus 1 whole cube. So which is nothing but, on simplification and on multiplying this minus z, so so this plus z and minus 2z, what happens here? So z of, so it is minus z minus 1 divided by z minus 1 whole cube. So therefore if you multiply this minus z inside, it will become what here? Z transform of n square will be minus z into this minus z, it will become plus z square minus minus plus z divided by z minus 1 whole cube. So this is our next standard function of z transform. So we need to remember what is z transform of 1, what is z transform of n, what is z transform of n square. So z transform of n square is z square plus z divided by z minus 1 whole cube. So this is one of the standard result. Similarly, we'll go for the one more result here, that is result number 5. That is result number 5. We'll see when k is equal to 3. So we know our property z of n raised to k is equal to minus z d by dz of z transform of n raised to k minus 1. So here if you put k is equal to 3, what happens? So z of n raised to 3 is equal to minus z d by dz of z transform of n raised to 2, that is n square. So which is nothing but minus z d by dz of, just now we know that z transform of n square. So z transform of n square is, z transform of n square is what here? Z square plus z whole divided by z minus 1 whole cube. We'll use this standard function result of this z transform and we'll simplify that. It is z square plus z whole divided by z minus 1 whole cube. So this is what here? Z transform of n square. So z transform of n square is what here? Z square plus z divided by z minus 1 whole cube. Now we'll differentiate this fraction with respect to z. So what we'll get? We'll see, that is z transform of n cube is equal to minus z denominator square, that is z minus 1 cube already we have to square it, keep the denominator as it is, that is z minus 1 whole cube. Differentiation of z square plus z is 2z plus differentiation of z is 1. With respect to z we have to make it minus, keep z square plus z as it is, and differentiation of z minus 1 whole cube is what here, 3 times z minus 1 whole square into differentiation of z minus 1 is what here, 1 minus 0. So on simplification we have completed the differentiation. We'll need to simplify. Z transform of n cube is equal to minus z, this will keep outside. So we have two terms, so this is one term completely and this is another term. So from the first term z minus 1 is also is there, and second term also z minus 1. So here power 3 and here power 2. So I will take z minus 1 whole square, I will keep outside. So what left we'll see. So z minus 1, so 3 times I have taken 2 terms out, 1 time is left, and already we have 2z plus 1 inside, minus among this z minus 1 whole square already had taken out. What left here, 3 times z square plus z is left here. So whole divided by z minus 1, 3 2s are 6 here is left. So therefore on simplification, so z transform of n cube is equal to minus z. So this z minus 1 whole square and z minus 1 whole raised to 6. So this completely cancelled with among these two. So therefore, and open the bracket, z minus 1 into z into 2z, it will become what here, 2z square, 2z square, z into 1 is what here, z. So minus 1 into 2z is minus 2z, minus 1 into plus 1 is what here, minus 1. So here open the bracket, minus 3z square minus 3z whole divided by z minus 1 raised to, so 2 is gone from this, so raised to 4. So therefore finally what we will get here, z transform of n cube is equal to minus z. So on simplification, 2z square minus 3z square, so how much here, minus z square. So plus z minus 2z, it will be what here, minus z, minus z, minus 3z, it will be what here, minus 4z, then minus 1 whole divided by z minus 1 raised to 4. So push this minus z inside, so z of n cube is equal to, you push this z inside, it will become minus into minus plus, so it will be z cube, then plus 4z square plus z whole divided by z minus 1 raised to 4, which is nothing but required standard function of z transform of n cube. So z transform of n cube is nothing but z raised to 3 plus 4z square plus z whole divided by z minus 1 raised to 4. So these are the few standard functions of our z transform. So in the next lecture we'll see some of the property which standard, some applications of what here, z transform, and a few standard formulas of what here z transform we'll see.